discussing today, okay, as for those who are new with OpenRoads and those who are quite a bit still hesitant on migrating coming from MXROAD. So that's what we will be discussing today. So I'll do a little of an introduction of how or what is OpenRoads Designer, okay, and why is it important to migrate. And then later on, I will pass it on to my colleague, Cornelius, who will basically take you through the contents as well as some specific migration tools inside OpenRoads Designer so you can get those MX data inside OpenRoads Designer. Okay, and then we'll leave some part for the Q&A. So just feel free to type in your questions as we move along, and then we'll address that later on in the day. Okay, now the main reason why we wanted to have this kind of webinar is to basically let everyone know that we are no longer in the CAD age. Okay, from where we rely upon computer aided drafting design software in terms of delivering our civil projects. Okay, and right now I think most of you are aware that we have this information modeling bandwagon in terms of delivering our projects. And then for those who are leveraging on the cloud-based technologies as well as maybe asset management in the later on part of project lifecycle, we also have what we call digital twin. Now, the importance of knowing why we in a way need to migrate to OpenRoads Designer is basically based on the typical infrastructure project lifecycle that we are exposed to. Okay, so maybe some of you are involved in just planning, okay, like survey or gathering survey data in the field and then creating conceptual modeling, and then probably some are more into the detailed design, okay, and up to construction as well as operations and maintenance. So all these stages of the infrastructure life cycle, okay, are very important, okay, and that's where OpenRoads Designer's strength comes in, because regardless of where you are in the infrastructure life cycle, the data that you create inside OpenRoads Designer are taken in from the very start of the project lifecycle up to the asset management. And of course, this is more or less like a vicious cycle. So any asset that needs or will fail at the end of, let's say, 30 or so years, okay, would need to go back to the same process again. And then the data that you have at hand is very important to be reused, okay, and leverage on so that you can continue on making sure that your asset or the data that you have are are reused and still beneficial no matter what stage of the infrastructure lifecycle you're in. Now let's understand the technology as well as the software itself. Okay, so for OpenRoads, actually, as I mentioned, uh, it can be used regardless of what uh, stages you're in the project life cycle. Okay, but specific to conceptual modeling, we have OpenRoads Concept Station. We also have another software called OpenRail Concept Station, but basically in the realm of conceptual modeling, so both OpenRoads and OpenRail Concept Station are the two softwares that we have for conceptual modeling. Okay, but if you move on to the detailed design, okay, for Bentley systems, we have this three major softwares: OpenRail Designer, OpenRoads Designer, and then OpenSite Designer. But of course, the focus of our webinar today would be more into OpenRoads Designer. So specific to roads as well as highway design, simple road alignment, uh, interchanges, okay, long interchanges or complicated or simple interchanges, we can do that inside OpenRoads Designer. Okay, now just a bit of a recap, because I think you know what OpenRoads, or hopefully you know what OpenRoads Designer is. But basically, in a gist, it's a detailed design application for the evolving civil infrastructure and highway market, and it has purpose-built tools for design as well as delivery of projects by using 3D modeling, and of course still producing your conventional construction drawings, also digital construction data, quantities, reports, and of course, as I mentioned in the early part, delivering a digital twin so that you can leverage on some of the cloud-based technologies as well that are available in the market right now, be it Bentley or non-Bentley solution. Okay, now a little history lessons for everyone. OpenRoads actually evolved from these three softwares: InRoads, Geopack, and then MX. Okay, and Malaysia, as we've seen it for the past few decades, you have been very tight users of MXROAD, okay, because most of the JKR standards are customized according to MX standards, okay, which are good because MXRoad is still Bentley software, okay. It's just that whichever uh, project you have, because some of you may be exposed to other projects as well. Some probably are aware of InRoads, then Geopack. Okay, but the thing here, why we have to make a common, okay, civil software, is that we don't want any confusions anymore as to which is the better tool or the best tool for civil design. Although each of these solutions are very much powerful in terms of delivering civil design projects, we wanted to make sure that there's a common, okay, common civil design platform that would take the strengths of each of these softwares. Okay. Now, before the full version of OpenRoads Designer, maybe some of you are aware that we have released InRoads, MXRoad, Geopack, using only some OpenRoads functionalities, okay, but still leveraging on the V8i technology, which is the MicroStation CAD engine. Okay, but then there are some challenges that our users pose to us, that in terms of drawing production, they are still doing multiple workflows, okay, in order for them to create and deliver drawing production like plan, profile, or cross-section sheets. So that's why, in alignment also to the MicroStation Connect edition, okay, that's when we released OpenRoads Designer. So OpenRoads Designer has the MicroStation Connect edition capabilities, both 2D and 3D, okay, plus all the civil design functionalities that you can find in the three other softwares: InRoads, MX, as well as Geopack. Okay, you can do, of course, roadway design, or we call it corridor modeling. Okay, you can create site design or land development types of project, and layout, drainage, and utilities, and do some hydraulic or hydrology calculation by utilizing some of the functionalities of StormCAD. Then we have some GIS as well as raster and reality modeling tools by adding in functionalities of another software which we call Descartes. If you have to add in functions of showing borehole data or log information. We have GINT civil tools, and of course, we all start with survey. Okay, so all these functions in one software only or one install of the software, OpenRoads Designer. Okay, but basically, if I may just maybe uh, literally uh, inform everyone that with OpenRoads, you're actually having three softwares in one. So MicroStation, OpenSite Designer, and of course, OpenRoads Designer. Okay. Now, of course, since it's a roadway design software, you can do terrain modeling, creation of your alignments or geometries. The strength is in the corridor modeling creation, grading optimization, of course, and we have this new technology, civil cells, wherein you can have a predefined civilized types of cells so that you can cater into creating those repeated types of civil objects like interchanges, ponds, and so on. And not to mention, of course, drawing production, which are now inside, already inside, and you don't have to really export them out to the old MXROAD, InRoads, as well as Geopack. And since it has MicroStation, of course, we have the visualization tool that is built in. But of course, you can output that to LumenRT as well, which comes in for free anytime you want a very realistic and real-time type of visualization. And of course, the what makes OpenRoads Designer very beneficial as compared to the other three solutions of Bentley is it really supports your BIM workflow. Okay. Now, in addition to that, uh, the reason, or maybe we can call it, or we can put it this way, why we are convincing you guys in a way to use or migrate to OpenRoads Designer is because of these 5 points here. Okay, and then I'll summarize that later on before I pass it on to Cornelius, because he has he has prepared a good presentation to you in terms of showing you the interface of OpenRoads as well as how you migrate the data from MX. Okay, so first point, common data format. So since we're leveraging on MicroStation, the format of OpenRoads Designer is plain and simple DGN, which is MicroStation format. So you don't have any external files anymore. Like for instance, in MX, you have some fill files or input files or Genio files, right? In order for you to create and edit your civil objects, and then you show them in your CAD platform. Can be MicroStation or even the other CAD platform, okay, which I will not mention anymore. Okay, and it's of course using the 64-bit latest platform of all the Bentley solutions. Okay, and aligned to every version, okay, or update of MicroStation. And OpenRoads is just one of the many open applications of Bentley systems that has the full functionality of MicroStation. Okay, so we have other solutions as well, but of course our focus is OpenRoads Designer today. Okay, so one format only, which is DGN. Okay, so regardless of you doing survey, creating terrains, geometry, viewing cross sections, creating your corridor models, or maybe coming up with your proposed design or terrain, so everything are stored as a database in the DGN file. Okay, so that's one point. Another point is, because of having a single data format, which is DGN, it's now easier for you to federate or manage all your civil data. Okay, so these boxes that you see represents, apart from the civil objects or the civil information, it also represents uh, a the unique DGN from where all these civil data or information are stored. So it's now easy for you to manage all your civil data as well as your file itself, because you're able to federate them or simply reference them in any which step, okay, you are in your civil design. Okay, now the benefit of federating or using the referencing model of OpenRoads Designer is, apart from it, or because of having DGN, okay, um, the OpenRoads Designer is designed to work, okay, in or to work with reference files in order for you to manage your civil data properly. Okay, and of course you just need to make sure, or maybe to make sure that you have, of course, proper file naming, object naming, or civil object naming, okay, which you will learn as you use the software. Okay, and then once you have this data accumulating, like for instance in terrain, maybe you only have one, or maybe it's better if I show it to you in this way. So maybe you have one DGN or multiple DGN that has survey information, even GIS information or reality models, okay? And you create another DGN to as the repository of your terrain model, but still referencing the survey. Then depending on the complexity of your project, maybe you have different sets of DGNs that has all your geometry files, both horizontal as well as vertical data. But anytime the terrain model changes, okay, so you're getting the latest data or information all the time, okay, whenever there are changes. So similarly, if you have a corridor model derived from all these geometries referencing the terrain model and of course the survey, so everything are if everything are federated well, you're getting the latest information all the time. Okay, and the same thing if you have managed to input or added some subsurface utilities, maybe your drainage networks, water networks, okay, you'd also be getting those benefits of having or getting the latest information all the time. And of course, maybe deliverables or arriving at 2D plan, the plan profile or sheet deliverables that you would later on um, need. Okay. Now, using this kind of approach, which is inherent already in OpenRoads Designer, you make your files or project files smaller. Okay, so if we have smaller files, we have faster way of calculating our or deriving some calculation at the end, especially maybe your quantities, reports, and so on. Okay, and it's of course easier to manage and recall where things are, and it exposes you, okay, to a multi-user type of environment, especially if the project is quite big. Okay, and you get more control as to how or when you need an information, or maybe arriving at different design scenarios later on. Okay, so that point number two. Point number three is ORD. I'm just going to show you some simple example here, but Cornelius will show a more detailed one later on. So ORD has a very simple data model. When you create your geometries, like in this example, your design intent are well preserved, and make sure that even though maybe you're doing more or less like CAD type of creation of your elements or your alignments, all of these are intelligent civil objects from where the design intent are preserved all the time. And anytime, like for instance, in this example here, if you're done with your geometry, okay, anytime any elements, in this case, the horizontal alignment needs editing, okay, you are sure that you're getting the right information because you the the object itself, okay, preserves your design intent regardless of what or where you are in your design workflow. Okay, so notice how the the annotations or dynamic annotations also are shown every time you click or manipulate your objects. And in any case, edits are done. Okay, all the other elements dependent on those objects also updates dynamically. Okay, so this makes it even easier and more efficient to use as compared to MX Road. Okay, and it's not anymore string based since everything are object or feature based. Okay, now another strength that makes ORD have a very simple data model is its template based way or manner of creating your corridor model. Okay, so although you have probably similar, you know, GUI or way of creating your corridors in MX, okay, but with OpenRoads Designer, okay, um, it's easier for you to create relationships from the points of your templates. When I say templates, these are your cross sections, okay, which could be typical or not so typical in terms of the type of corridor you're creating. So each points can be dynamically constrained, thereby creating components, okay, and probably creating end condition like what you're seeing here. There's a way for you to see and test it as you design it, so that when you use it, it will reflect, okay, the design scenario that you want to achieve. So like for instance, this is one example from where an end condition, or maybe uh, not really end condition, the center, okay, or median of two adjacent road on the rightmost as well as on the leftmost part of the corridor. So if there's a way to dynamically, or there's a need to dynamically create relationship depending on your existing, okay, ground condition, um, OpenRoads Designer allows you to easily create those types of relationship in your templates. Okay. Next, which is actually the theme of our webinar today, is OpenRoads can allow you or can give you a centralized standards. So like for instance, in this case, if you have the Malaysia, okay, workspace or data set, it gives you a centralized standards in terms of creating or delivering your project. So the workspace and work sets, as you will see later on, is more or less a repository of your standards as to how your alignments would show in 2D or maybe in 3D, and how your annotations as well as your sheet models would show or be rendered when you need to do drawing production. So with a centralized type of workspace and work set, it makes it easier for you, okay, more or less to make sure that you're following, okay, maybe an industry standard, or if it's imposed by let's say hopefully JKR and other Malaysia authorities, okay, all they need to do is just probably give you this workspace and you do or you deliver all your projects, okay, based on these standards. Okay, now we'll give you a better look at the Malaysia standard, although my slide here shows Singapore. Okay, later on when Cornelius pushes on with his discussion. Okay, now one second to the last point, or last point I want to reiterate is its dynamic uh, way, okay, of creating BIM model from start to finish. So this is your typical, probably your typical workflow in delivering any civil projects. Okay, maybe starting from survey data, deriving terrain from it, and creating uh, site models, and of course your geometries, okay, templates, corridors. Okay, so regardless of what stage you're in, um, OpenRoads Designer starts with what we call feature definitions, which basically is what we can say the first step in achieving a dynamic BIM model. Okay, the major challenge with MX string-based technology is that it's not really scalable in terms of creating your 3D objects or maybe volume calculation, which are required in any BIM deliverables. And MX, in a way, is not really or a bit short in terms of you proceeding to the next step of doing maybe 4D construction sequencing, or maybe your 5D cost analysis. Okay, so with OpenRoads, okay, let me just. Okay, so let me just put it back. So an information-rich model is the fundamental component of any collaborative BIM. And when creating design elements in OpenRoads, attribution are applied automatically using feature definitions, as you can see here. And in this example, the pay item information is already included when we create curb break lines. Then when we create maybe another break line, which is maybe the back of the curb, it has feature definitions already assigned to it. And we see that their corresponding pay item number, this is just an example, are also added. Okay. Inclusion of information extends to any singular point element as well. So like in this example, notice the speed point element as well. Like in this example, oh wait, let me just push it a little bit because, okay. There are information, oh, sorry. Let me just go back. Sorry. Okay. And push it a little bit here. Okay. So the inclusion of information extends to any singular point as well, or singular point element as well. So like, for instance, in this example, so notice the speed, the sign designation, as well as sign dimension are specified as we place the speed limit sign in our design model. Okay. So custom attribution of relevant information to our design elements within the model allows us to enhance the value of the design model. So in this case, we can add or call out pay item number, specification for seeding or maybe mulching of the roadway side slopes. Notice that additional properties from customized lookup table are or can be automatically included as well, and we can assign them directly to the object models. Now, feature-based modeling in OpenRoads allows us to more or less parse the design model, not by CAD standards such as level, color, line styles, but by assigned element definition. Okay, basically we are able to interpret not only the, or by, not by things, how things look, okay, but by actually making sure it has the real world property. So like for instance, in this example, as you select your objects, it highlights in the model and gives you a good properties or properties that allows you to make or get the right information, okay, civil information in from the model. One of the advantages of true information model are expressed in its property-driven annotations, as you can see here. So properties are inherent, okay? Like for instance, the speed sign that you see has specific properties. And all of these examples from the start that I have shown, okay, provides us foundation from which efficient model-centric reporting can also be achieved. So like for instance, extracting or maybe creating tables that are dynamic is also very important in your workflow. And as we create this report, you can place it in your models, okay? Customize it according to what you prefer. And all these are dynamically linked from your civil objects. And this reporting, okay, can ultimately be extended to a spreadsheet by exporting the report to Excel for distribution and further customization based on your company templates. Now, to sum that up, okay, just a bit of comparison on MXROAD and OpenRoads so that more or less you really understand where we're at in terms of the benefits, okay, of using OpenRoads Designer as compared to MXRoad. So most of you know that MX is string-based modeling, but for OpenRoads, it's template-based. You don't require multiple file formats in OpenRoads. You only have the DGN to rely on. And of course, since it's not file-based, it is relying on workspace, which Cornelius will reiterate later on. Installation-wise, we only have one mode, which is standalone. As compared to MX, you have an option to install it either in MicroStation or in AutoCAD. Okay, but of course you don't need MicroStation. Okay, in order for you to install OpenRoad. It's just that we want to reiterate that OpenRoads or MicroStation is already inside OpenRoads. So as I mentioned, 64-bit is now the way forward. Okay, we have robust interoperability, especially supporting all your BIM workflow, which is kind of limited in MXRoad. And since we have stopped any developments in OpenRoads, there could be operating system limitations, okay, and which are not okay present in OpenRoads because we try to make sure that we are synchronized with any OS updates. Okay, and OpenRoads is really our or Bentley's core civil design platform, and expect that we have more innovations in terms of making sure that you are at par with any technologies, okay, that will come in the market very soon, especially in the civil design world. Okay, so I'm now gonna turn over to Cornelius for him to discuss more on the technical side of things in terms of the migration as well as the contents of the Malaysia dataset. Cornelius?
Right. Thank you, Maylin. Let me
Welcome.
just quickly share my screen. Okay, so hopefully you guys can all see my screen right now.
Yep.
Okay. All right. So thanks again, Maylin, and hello everyone. Good afternoon. So for my part, I'll be sharing with all of you, right, on the migration of data from MXROAD to OpenRoads Designer. And of course, this will be covered in greater detail during the hands-on demo that we are going to show or we'll be sharing with you guys later on. And it will be basically showing how we can easily import the data file that you may have created in MXRoad directly into OpenRoads Designer. Okay, so now let's just take a quick peek at what we have already set up in the Malaysia standards dataset up to this point in time. So as of now, we have the geometric design standards that has already been added based on the JKR ATJ 8/86 Pindaan 2015, all right, along also with the super elevation design standards as well. And of course, both of this is formulated based on the JKR Arahan Technique Jalan, yeah. And at the core of the dataset setup is, of course, the drawing production standards configured via what we call the sheet or rather the drawing template, right? And this drawing production standards will come with the associated annotation setup, and that actually includes the annotation style, like how the annotation will be presented, the text, the information, and all the related data that is extracted from the geometry and cross-section views, right? As well as the text styles associated with that. Now, this annotation is also automated. So once your model is done, you have the 3D, you have the geometry corridor model all done, then we can actually just apply the annotation group to it using the drawing seed, and everything will be done in the background by OpenRoads Designer. And we will be sharing with you how this is actually done, the workflow to actually go through this entire drawing production process. Okay, so a brief look into the Malaysia standards dataset when it is brought or actually deployed into OpenRoads Designer. Okay, and please do not worry if all this setting up configuration is looking a little bit overwhelming or a bit confusing, because this will eventually be covered in more detail as we head into the hands-on demonstration later on. Yeah. So let's take a look at later on how we can actually deploy the data set. So what you can see here, right? Once we deploy the data set into our machine, then we can actually set up the workspace and work set like what Malin has briefly mentioned earlier. Okay, so what forms the backbone of this workspace and work set is basically the data set, which is coming from the Malaysia standards data set configuration. Okay, so first of all, this is the thing that we really need to set up before even start creating files or opening files inside OpenRoads Designer, in order for us to load all the settings and the standards that has been set up for us. Okay, so as you can see, once we have loaded in the workspace and the work set, right, you will be able to see the design library being loaded in, and this is how it will appear in OpenRoads Designer, right? So if you open up the design library, you can see that there is this Kerajaan Malaysia ATJ, and we have the rural areas based on maximum super elevation of 6%. We have the urban areas, so we have created for 6, 8, and 10% respectively. Yeah. So this is for the geometric design standards of based on the ATJ. And of course, not forgetting the super elevation design standards as well. So for the super elevation design standard, is a little bit different. All right. For the geometric design, it is all stored inside what we call a DGN LIB file. Whereas for the super elevation design standard, it is stored in a .xml format. Okay, so in this XML format rule file, it will have to be loaded manually when we actually activate the calculate super elevation command in ORD. And of course, this will be shown later on in the hands-on how we can actually activate this rule, okay? And how do we bring in the rule that we want? So as you can see here, we have set up the super elevation design rule based on the 6% maximum, 8 and 10% respectively as well. Okay, so we will take a look later on how we can actually call out this super elevation rule, and then how we can just very quickly specify what is the design speed we want, and whether the pivot method is along the crown, along the edge of the road, and things like that. Okay. So as for the drawing production, okay, now what we have right now is the plan and profile drawing sheet, or what we call the sheet sheet, right? The drawing template basically. And this can be selected from the drop-down list, as you can see here, right, in the option drawing sheet. So this can be selected from the drop-down list. And inside this drawing sheet, it contains the setup that includes the offset, right? The left and the right offset, the length of the name boundary that we want to create. So basically, setting up the extent of the drawing size that we want, as well as the drawing scale that we want to apply onto that particular model, right? And this also includes the title block as well as the annotation scale within the setup drawing sheet. Okay, so we will take a look at how we can actually apply this drawing sheet, okay, and see what is the output that comes out from OpenRoads Designer. Okay, basically everything has been set up in the drawing sheet, but that does not mean that it is fixed. All right, so even though the settings here are configured or pre-configured in the drawing sheet, that does not mean that the user is confined to just using the values that are here. All right, it will be still flexible enough that we can change the values according to our project requirement. And over here is just a sample output of the drawing that is created in ORD, and we will see how automated it is and how easy it is for us to just generate drawings like this, both a plan and a profile within a given title block. All right. And similarly, of course, this is something that we will explore a little bit more, focus on later during the demo. Now, moving forward, what is next for the Malaysia Standards dataset, and how do you, as the users here in Malaysia, can actually play a part in helping us to develop the dataset? Yeah, we are currently actively collating the as much information as possible in order for us to actually continue developing the dataset. And right now in the pipeline, we have plans to add on to the template library, as what Millen has mentioned. So template is basically just the typical cross section. So we are planning on adding in the template for the road cross section, and as well as eventually adding in the cross section drawing template or the sheet sheet. Okay, so the sheet sheet is currently a work in progress, and we will actually be showing you guys a sneak peek of what we have up to this point, all right, later on as well in the demo. But most importantly, all right, all of this boils down to all of you as the Malaysian users, because you are our best avenue to gather the feedback and comments, as well as sourcing for information, right? And this feedback and comments that we get from all of you will eventually help us in the further development of this data set. So after this session and all, it would be much appreciated, you know, if you guys can actually just help us test out some of the things that we have set up, and then give us the required feedback, or you know, things they may need to be improved and added on later. All right, so I'm just gonna stop with the slide now, and I will move on to the hands-on presentation or the demo, showing how we can actually deploy the dataset, as well as how do we apply those settings that we have set up in the dataset into a model in OpenRoads Designer. Okay, so let me just launch right now. So now as we go
Is it better now?
into the
Yep. All right. Okay. Thanks.
start, right, of this OpenRoads Designer Connect Edition for especially using the Malaysia Standards dataset. Okay, so it's very important that we need to know how this actually works, as mentioned by Maylin, right? So all that we are using right now actually is contained within the DGN library or the DGN lib file. Okay, including all the configuration, the setup, the design standards, the drawing seed and all that. Okay, and this will also apply as well to what you have seen earlier that I have presented. Okay, so basically all of those annotation groups, the drawing production is all contained within the data set. Okay, so where can we actually find this? Now, I will be sharing with all of you the links to actually download the beta version of this work in progress Malaysia standards dataset, all right, which you can then deploy into your machine, and of course this will have to come with your OpenRoads Designer Connect edition. Yeah, so you have to have um, the software installed on your machine, all right, before of course you can actually make use of this dataset. All right, so where can we actually deploy this dataset? All right, so it is actually located in your C drive. Okay, so let's just go through this very quickly now, but at the same time, please do have a sensing, right, of where should we be keeping all this data sets stored, okay, because it is actually the central repository for all the standards and the designs like I have mentioned earlier. All right, so this is where we actually keep all of that data. So under your C drive, okay, in your program data folder. Now, some of us we may not be able to see this program data folder, and it is for the reason that the program data folder is actually a hidden folder. That is why you can actually see that it's actually a little bit grayed out. So what you can do if you're running Windows 10, all right, you will want to go over to View, and then under the Show or Hide, you want to check this box Hidden Items in order to bring it out. All right. So by default, the hidden items are usually not checked, so it will be not showing at all. Therefore, if we want to show the hidden items, we just need to check this box. All right. And then we will be able to see the program data folder, right? Then I will just go in this program data folder and then looking under the Bentley folder. Okay. So if you already have your OpenRoads Designer Connect Edition installed, okay, then you will be able to find it in the list of folders here. So if you're running the previous version of OpenRoads Designer, it will be simply named as OpenRoads Designer CE, which stands for Connect Edition. But starting from release 2021, release 1, yeah, all right. So OpenRoads Designer version 2021 release 1, or what we call the 10.10 version, we have started allowing side-by-side installation. So major updates can be installed side by side, meaning that you can actually run two different versions of OpenRoads Designer on the same machine. All right, as opposed to previously where if you were to install the latest version, it will simply just override the previous version. All right, so now starting from 2021 release 1, um, side-by-side installation is allowed. Therefore, you will be able to see two different folders for the different version of OpenRoads Designer that you are running. Okay, so I've also included the installer for OpenRoads Designer CE 10.10, all right, or the 2021 release 1 version, in the links that we'll be sending over to you guys shortly after the session, right? So I've also included the link for um, the installation package really, where you can actually install OpenRoads Designer of the latest version. Now, going into this folder after you have installed your OpenRoads Designer, okay, you will be able to see a configuration folder. All right. So under the configuration folder, you can see a few of these folders like the organization civil, and workspaces. Okay. So within the what do you call it? Within the links that I will be sharing with you, yep, you will be seeing this file that I have uploaded. All right. So within the file for OpenRoads Designer, right? I have here the beta version folder as well as the OpenRoads Designer 2021 release 1. Okay, so under the beta version folder, there is this organization civil and workspaces. Now under the organization civil folder in itself, you will be seeing Malaysia Standards folder and the Malaysia Standards.cfg file. Now this .cfg file is simply the configuration file that governs the settings and configurations that will be loaded into OpenRoads Designer. and what data is actually pulling up from this data folder called Malaysia standards. Okay, so this is what we're going to do. All right. So in the configuration folder, I have purposely named this two folders the same as what you will see here. All right, which is organization dash civil and workspaces. So what we're going to do is you're going to copy the contents of this organization civil folder into this organization civil folder. Okay, so match the name correctly. All right, so word by word it is the same thing. And here you will see that I have already done it here, Malaysia standards folder and the Malaysia standards.cfg file. All right. Now, similarly, in the workspaces folder, I have also created the workspace called Malaysia Standards, and it is accompanied by, of course, the CFG file. All right. So if I go back into this configuration folder under workspaces, you'll be seeing Malaysia Standards and the Malaysia Standards.cfg. Now, within this, I have, of course, copied in the work sets as well, but I have removed all the others except for JKR work set, all right, which we will be using in the demo later on. All right, so basically what you have in the link that you will be receiving after the session, okay, in the beta version folder is the folders containing the organization civil folder and the workspaces folder, which you would need to deploy into this configuration directory. All right, both these folders will have to be added into. Okay, so once you have added in the folders and the files contained within this link, then we can just go ahead and launch our OpenRoads Designer Connect Edition. Now, you can also see that I have both the OpenRoads Designer running side by side here. So I have the 2020 release 3 here. All right, I have the 2020 release 3. And then, of course, I have running right beside it the 2021 release 1. Okay, so I can be running two different versions of OpenRoads side by side right now. So I'm just going to go ahead and open up OpenRoads Designer, right? 2021 release 1. And let's see how we can actually apply the data set that we have set up into any design file that we are going to create in OpenRoads Designer. Okay. So first of all, of course, we will need to set up the workspace, and as mentioned earlier, I have already set up the Malaysia Standards workspace. Okay, and you should have the JKR work set appear automatically, right? So you should not have all these options because all I have given in the link is basically just the JKR work set. Okay, so with this JKR work set now, what I'm gonna do is I would begin following the civil design workflow. All right, starting from the terrain modeling. Okay, and to do that, I will simply just go ahead and create a new file right now. Okay, and I can save it anywhere in my machine. So I will just put it in here. Okay, so I'm just gonna go ahead and name this terrain model. Okay, now this is very important, yeah, my friends. Okay, this is very important. The naming itself, not so much, right? But what is important here is the seed file. All right, my friends, take a look here. The seed file. So right now, by default, the seed file that is being used is the seed 2D metric design. Okay, but of course, we can also set this up. All right, if you go to browse, then it will bring us to this directory of the Malaysia Standards folder, where we have this seed 2D metric design, rail design, site design, as well as a seed 3D metric design. Now, when we deal with all this terrain modeling, okay, we are actually working with three-dimensional data, right? X, Y, and Z data, which is why we will actually need to call upon a seed 3D file, okay, a 3D seed file. And that is simply just because of the fact that terrain models are going to be created using X, Y, and Z data. Okay, so it's a three-dimensional data. That's why we need the seed 3D. Now, that is the only thing I need you all to remember when you are creating a new file. Because as you remember this, terrain model equals to 3D seed file, then you can just remember that all other files should be created using a 2D seed file. Okay, and that includes alignment file, your geometry file, right? Your super elevation file, your corridor model file, your drawing production file. So all of that should be done in a 2D seed file. And the only thing that you should be using as a seed 3D is actually for your terrain modeling. Okay, so that's what we're gonna do starting first. So I'm just gonna go ahead and create a file using this 3D seed file. Yeah, so I'm just gonna go ahead and open, making sure that it's using the seed 3D. Then I will just go ahead and save to actually create the new file. Okay, so you can see over here right now, it's going to load all of the DGN libraries that is contained within the workspace, all right, into this file so that we can actually use it for our onwards design within this workspace and work set that we have set up earlier. Okay. All right. So now this is just a empty DGN file. Okay, I can see that as I go ahead and fit view, there will be no elements file, meaning this is simply just an empty DGN file. Okay, now assuming that you have already designed something in MXROAD, okay, which is basically your terrain model that you have created in MXROAD, and now I would want to bring that model into OpenRoads Designer. Okay, now it is very simple to do that. All right, so I'm just going to share with you how we can actually do that. So over here at the top, right, over here at the top, you have all the tabs set up quite easily laid out for us. So you have the terrain tab, which is for the purpose of terrain modeling, then the geometry creation tab, corridor modeling tab, and then finally drawing production tab. Anything in between is basically tools that are available to help us refine our modeling work, our design works. Okay, so if I go into the terrain modeling tab now, I can simply just go ahead and import your terrain model from an existing file. So I can just go ahead and import terrain model from file, and I will just look into the folder, all right, where you know where it is stored. So I have this FIL file that contains the terrain model as well as all the other geometry models inside it. So I'm just going to go ahead and double click on this to open up the file. Okay, so over here, you can see that I have all the, of course, the contours, the design, right, and the survey as well, right? So I can have this, and what I would do next is basically I would just go ahead and import in this survey triangles over here. And to top it off, right, knowing that this is a project in Kota Belud, all right, Sabah, I can simply just set all these things up, like the source file units. If I know it to be meters, I can just set this up at meters. Okay, and for the GCS, now this is especially important for us civil engineers, right, civil designers. All right, um, geographical coordinate system. We need to have our project properly geo-coordinated in order for the project site to be exactly where it is supposed to be. Okay, so I'm going to assume that I do not know where this is in Kota Belud. I only know it is somewhere there, somewhere in the vicinity of Kota Belud, Sabah. Okay, so what I'm going to do is I will just set this, what do you call it? The geographical coordinate system over here. So I have the option to set it over here, or I could simply just set it over here so that it is targeted to a certain projection system which is attached to this file. All right, so I can do it over here as well, where I can simply just left click on this icon with the three dots to bring up the GCS library. Okay, then I can just set up the projected coordinates under Asia, right? So you can see here under Malaysia, we have a multitude of libraries over here. Okay, so I'm just going to take my best guess and use this Malaysia ISO Sabah, Eastern Malaysia Sabah coordinate system. Okay, but of course, if there is another geo coordinate system in use, then you can just set it up yourself, all right, and add it into the favorites, or you can just pick from the list available over here. So assuming that, all right, assuming that this data is this project is using this Malaysia ISO Sabah, I'm just going to go ahead and click on OK. And then finally, I just need to go ahead and import this data into my file. Okay, now once I've done importing, you can see that it will show as import complete, and I can close the window. And once I fit view, I will be able to see the triangulation over here. Okay, the imported triangulation. Okay, and this is already a DTM, all right, a digital terrain model where it gives us the elevation. Okay, it gives us the elevation value. And if I were to just rotate the view in a dynamic, right, I can actually see how it is, it is in a 3D. Okay, so this is already a 3D terrain model. Okay, so this is what we have now, bringing in the data from our FIL file, which we have created in MXROAD. Okay, so this is how we can very easily just and quickly just bring in any data from MXROAD terrain model right into OpenRoads Designer, and then basically converting it into a model that is consumable in OpenRoads Designer. Okay, now over here as well, I can then begin manipulating what I want to see, like the display style. Right, so I can actually turn off the triangulation, leaving just the boundary here like you can see. Okay, but most important of all, I need to make sure that the geo coordinate system that I have applied, all right, the Malaysia ISO Sabah, is correct. So I can actually do a very quick check by going to the view attributes here. Okay, this icon here, view attributes. And then if I go all the way to the bottom here, you can see that there is a background map tool. Okay, a background map tab actually. Then I can simply just select maybe an aerial map. All right, and you have to have the internet connection for this to work, because what is going to happen now in OpenRoads Designer is it will actually stream the Bing map directly from Microsoft Bing server. So you can see here, I may not be very far off, all right, or I may be very far off, I'm not really sure, all right, but anyway, this is just for us to have a very quick check on whether our project site is exactly at where it is supposed to be. Okay, so you can have a different option as well. You can have a hybrid map, which is a street map plus aerial map. Okay, so with the street map, you have all the what do you call it? The labels. Okay, so I have all the kampong here. So Kota Belud is over here. So I may be a wee bit off the trail. Okay, but I'm just gonna assume that Kota Belud is basically the district here. So let's just assume it is at the right place. All right. So now that we have established that we have properly geo-coordinated this what do you call it? This terrain model. Okay, I can simply just go ahead and turn off the background map. Okay, so now we have successfully imported our terrain model from MX into OpenRoads Designer. Right, so next up is, probably you may ask me next, if I also have my horizontal and vertical geometry done, how can I possibly bring those data in as well? Okay, how can I possibly bring those data in as well? So same thing, but this time around, I'm just going to go ahead and create a new file, and this will be in line with what Malin was presenting earlier, which is the federated model approach, okay, where we tend, or rather we recommend and encourage the users to actually create and store your files in individual DGN for each different models, like one DGN file for your terrain model, one DGN file for your geometry model, and so on and so forth, right? So this is where this federated model now comes into play. So I have a DGN model storing my terrain model right now, and now I will create another DGN file for the purpose of storing my geometry model. So I'm just going to go ahead and create a new file right now, and let's just call it geometry. And this time around, my friends, remember this seed file. As I have said, 3D seed file is only used, okay, is only used for the creation of terrain model. So everything else we should be using seed 2D. Okay, everything else seed 2D. Terrain model seed 3D. Okay, so I'm just gonna go ahead and select the seed 2D file now, and then same thing, save this file so that we can just open up the file. Okie dokie. All right. So again, this is just an empty DGN. Okay, this is just an empty DGN. Now I will bring in the geometry similar to how I have done it for the terrain model, but I wouldn't be able to do it from this here. Okay, even though when I do this, okay, I can actually just bring in the design and the purpose, which is actually the geometry, what do you call it? The geometry model, but I will not be doing that. Okay, instead, I will actually go into geometry. Okay, so you can see how the naming is very clear cut to us. Terrain is simply for the import, the creation of terrain model or exporting your terrain model, and geometry is, well, as the name suggests, for the purpose of manipulating, editing, creating, importing, and exporting of our geometries. Okay, so I'm just going to go ahead and import the geometry now, and I'll be using the same file as I have earlier. So I'm just going to go into Bentley internal, okay, and I will just look for this model file again, this FIL file. Okay, it's just going to load all the data within that FIL file. And right now, okay, I am just going to bring in this proposed alignment, okay, and as you can see here, the proposed alignment contains the default GC20 alignment as well as a planned linear default MC20. Okay, so what is going to happen now is I will simply just click on import, but before that, if you wish to apply a certain feature definition to it, okay, if you intend to apply a feature definition to it. Now, before I get into what a feature definition is, okay, right here, I have created one for the purpose of um, assigning all those annotation groups to a certain feature definition, all right, for the Malaysia standards users, okay, the Malaysia standards dataset users. So this here, my underscore geom, is created solely for the purpose of assigning the annotation group onto this feature definition such that whenever you use this feature definition, there will already be a certain set of annotation style, text styles assigned to this particular feature definition. All right. So for this exercise here, I will just be using this linear feature called my underscore geom, and then I will just click on import. And usually I will just set this as create civil rules. And why is that? Because I want the geometry that is being brought in to have the civil rules so that I can easily manipulate them as part of a geometry instead of just a line string. Okay, so I will just import this in now. And then as I go ahead and fit view, I can now see that I have this geometry over here. Okay, and this is just the import part of bringing in our geometries and things that we have created in our previous exercise in MXROAD. Okay, so over here you can actually see once I select that geometry, it would have contained all the civil properties like the radius of the arc, right? Um, and also the spiral length, right? You can see the spiral length here. And what this does is when it is brought into the OpenRoads Designer, I can very simply just click on any of these tags here and I can do a dynamic edit to it. So I can just type in the value that I want, say 200, and you can see how quickly it actually updates. Now what is behind here is actually the 3D linear element, which is basically the profile of the geometry. Okay, but how this is done now in OpenRoads Designer is, let me just revert back to 250 meter for the radius. Okay, is that if I wanted to have a profile attached to the horizontal alignment, I will need to bring out this profile model. So I can just click on the alignment and then hover about it until I see this interactive toolbar. Then I can just go ahead and click on Open Profile Model. And then over here, you will see that it is just an empty blank model. And this is because we do not have a terrain model for it to have the existing ground profile imprinted on it. Okay, so what I need to do is to actually bring in the terrain model that we have created earlier as a reference. Okay, now before I do that, I will just go over to utilities over here. Okay, and I will simply just set up the coordinate system similar to the one that I have used for the terrain model. So I will just go ahead to Asia, Malaysia, and RSO Sabah. Okay, so I will be using the same type of GCS. Then going back to home, I will look for this attach tools. Okay, and then I can then bring in the terrain model file. Okay, making sure that it is coincident world so that it follows the GCS of the the global origin is aligned with what I have set up in this master file here. So I'm just going to click on OK, and you will see that over here is the terrain model. Now what we have in the profile model here is simply just an empty model, yeah. But take a look at what happens when I do this. Okay, so remember that this is simply just a reference file. Okay, this terrain model is just a reference model. But if I were to click on the terrain model, I hover about it for a little bit, and then I set it as the active terrain model, right? So the moment I do that, if I go back into my profile model and I fit view, you will be able to see the existing ground profile appearing now. Okay, so in order for this to happen, we need to set a terrain model as the active terrain model so that it will be presented or displayed onto the geometry. Okay, so this is now the existing profile, right? And after I've done that, I can simply just go and undisplay my terrain model. Okay, so I can simply just hide the display. I'm not actually removing it or deleting the terrain model. I'm simply just hiding the display. All right, so going back here. Now we will have to design the profile ourselves. Okay, we will have to design the profile ourselves. Or a better way is, since we already have the profile, which is the 3D linear element, I could simply just call upon the geometry tool under the vertical profile here. All right, and I can simply just create a profile by the 3D element. Okay, so I can do that, and then I can just locate the element to profile, which is GC20, and then you can see that there is a 3D element behind it, so I can simply just select that as well. Okay, Now, what is happening is it actually already creates the profile, but it is not the correct profile as I have observed. So if I were to fit view, you can see that it actually creates a profile right here at a elevation of minus 1000. Okay, so I will not be using this profile. Okay, I will not be using this profile. Instead, I will be designing the profile in OpenRoads Designer. So when we are designing a profile in OpenRoads Designer, this is where we will need to call upon our design standards, right? So where can we find that, my friends? It is over here, all right? So this is usually not there, and this can be found under geometry, under standards, and then you have the design standards toolbar. Okay, and I would usually just because it is a floating window, I would just usually pin it to the top. Okay, and if you click on the drop down here, this is where you see all the standards that we have set up under Kerajaan Malaysia ATJ /86 Pindaan 2015. Yeah, so you have the rural area with the different maximum super elevation value and the urban areas as well. Okay, so let's say this is for a rural area with a maximum 8%. Okay, and then under it, you have also the different class of road where you have R1 all the way to R6. Okay, so I can just select any of this. So you can see under R6 is for the higher speed, and for R2 and R1 is for the lower speed design speed, right? So let's say I want to go for something about R4 standard, okay, and I'm using 70 kilometers an hour. And all I need to do now is to toggle the active design standard. All right, now take a look at what happens now. If I go into my complex geometry and using the profile complex by PI tool, okay, I will actually have the curve lengths set up for me, right? So I can simply just change this value right now. Okay, and you can see the vertical curve parameter is set up for me. Let's say if I were to change it to a different value, let's see how it changes. Yeah, so let's say 800 kilometers, you can see the vertical curve parameter. Okay, if I were to use a lower road standard, say 40, you can see the vertical curve parameter is only 10. Okay, so all of this is set up in the design rule. All right, and if I may go back just one step into the horizontal geometry portion, it is the same thing. All right, it is the same thing if I use the complex by PI. Okay, so what I have here is using the 40 kilometers an hour, so it gives us a radius of 60 with length, spiral length of 29. But if I were to use a higher design speed, say for example, 120 kilometers an hour. Now look at the radius here, my friends. Look at the radius and the length of spiral that is going to be applied. Okay, so it's the same thing both for the horizontal and the vertical geometry. Okay, so let me just go back to the vertical geometry, and I'm just going to simply, create a vertical geometry for this particular horizontal alignment here. Okay, so I will just simply create something. So I'm just going to go ahead and do a little bit of trying a balancing act of cut and fill, hopefully, right? Okay, so I have a problem here because I cannot fit in a profile curve length of 50. Okay, so what I need to do now is I will definitely need to use a lower speed for this due to the mountainous terrain. Yeah, so I'm just gonna go ahead and try something here. Okay, then maybe I will do something like this. Okay, so you can see here that we will have some error warnings telling me that the crest value is less than the default. Now the default meaning the one that we have set up based on the JKR standards. Okay, so this is a warning sign, all right, that prompts us that as the user we should be taking a look at this crest value, because it is definitely just giving us a value of 10 instead of the minimum crest K value of 15. Okay, then what about this? The slope is less than the minimum. Okay, so the minimum is actually 0.5%, but we only allow for 0.4. So I'm just gonna go ahead and tweak this a little bit. Okay, just gonna tweak this a little bit so you can see the value actually changes as I move my points, right? So I'm just gonna do this like so, using the graphical um, method, all right, using the handles. But of course, you can also do this by using the text manipulator over here, where I can simply just type in 0.5% and it should help me adjust this. Okay, so all the others here, I can simply just go ahead and change what I need to change, provided that is within the constraints that we are um, constrained to, okay, based on the design standards, obviously. Okay, so I can simply just move this around so that it gives us a better design, right? And obviously I cannot really do much about this due to the steep ascent, okay, but I can try doing a little bit of a tweak here. Okay, maybe just try to move this a little bit further to the right. Okay, and this is also another steep ascent of 12%. All right, so like I said, this is not an ideal design, definitely, but just for the sake of this exercise, all right, in a real project scenario, of course, it will be up to us designers to actually come up with a balance for this. Either we cut off the heel, or we have to do something else about it. Now, once we have this profile design, which is based on the JKR standards, of course, 40 kilometers an hour design speed only. But I have not resolved this yet, as you can see. All right, but we're just gonna leave that there, no problem. Okay, so what I'm gonna do next is I will simply just go ahead and set this as the active profile. Now this is important, yeah, my friends. This is important. Why? Because eventually down the road, when we want to do the profile annotation, it will actually um, recognize this as the design profile. So we will need to set this as the active profile. So OpenRoads Designer knows that this is our design profile. Okay, so I will just set this as the active. And next, we have the horizontal and the vertical geometry done. All right, so what is next? Okay, so next up is, if you want to go ahead now and annotate your geometry, you can do so already. Okay, you can do so already. So I'm just going to go ahead very quickly into drawing production now. And for the horizontal geometry, I can simply just do an element annotation here. Okay, and left clicking on the geometry I want to annotate, and then right click on it, let it process a little bit. Okay, and you should be getting this annotation coming out. So all of this has been set up to read the spiral curve parameter. Okay, and of course there will be issues like this somewhere because the offset is fixed. Therefore, when the curves are actually a little closer to each other, like so, where the PI points are further away, this text will be a little bit further down. But that is not an issue, I suppose, because we can very simply just select the text and then move it to where we want it to be. Okay, so that is for the annotation text. Now for the profile, we can do a very quick check in 2021 release 1, where we can simply just annotate the profile here like so. Similar thing, but instead of going to the annotation, I would simply just do it from here. All right, annotate element, and then you can actually see it from here, right? All the VIPs, and of course the chainage and the elevation of the curve to tangent point and the tangent to curve point. All right. Uh, but I do have an update for you guys here where we have a limitation with the software where we are not able to extract the information for the difference in grade. Okay, the information for the difference in the grade value for the incoming and outgoing tangents. So for this one, we may need to just do it manually. Yeah. All right. So this is something that is limited by the information that is stored within the geometry. So not something that we can actually extract out from the text favorites. Okay. So with this done here, you can actually go on to your drawing production already if you want, right? And that is actually what I'm going to show you guys next. All right. So we have the plan and the profile. Now, how do we create a plan and a profile drawing in a sheet model? Okay, so I just need to go over to name boundary here right now. Okay, using a place name boundary. Then, as shown in my slide, you can go to the civil plan mode. Under the drawing sheet, I have created as well the Malaysia plan profile. Okay, for the plan of 1 in 1000 scale. All right. So once you select this, you can actually see all the settings have been configured for us already. Okay, but for this exercise, when you're creating the plan name boundary, remember to turn this off first, the create drawing box, and then just select the center line of your geometry. And I will just move from left to right. Okay, so that I can see that the box created is like so. All right, so if you're happy with the extent of this box covering everything that you want to see, I will just go ahead and left click now to accept that. Okay, and then I will actually change my text size to 1 in 1000 simply because I want to make sure that all the texts are in place. So you can see here that this has gone beyond the boundary. So I will just need to make a slight adjustment here by pulling it back closer into the name boundary. Okay. Now, similarly for the profile. For the profile, I'll go into the name boundary and then using the civil profile mode. All right. I will use the Malaysia plan profile and then making sure I'm actually using the method from plan group so that it coincides with what we have on plan. And all the settings are configured as well based on the drawing sheet. So I would just turn on this create drawing right now. Okay, and select this profile model. All right, but you can actually see that with the given height and all the settings, I will not be able to fit it inside the name boundary. So what I need to do is probably I may need to make some adjustments and set the vertical exaggeration to 5 instead of 10. And now you will be able to see that I can fit in the profile. Okay, so you could try this out. Of course, by standards, it should be vertical exaggeration of 10, but in this exercise, because of the huge elevation difference, okay, I will just go with a vertical exaggeration of 5, okay, so that I can fit this in, right? And then what I'm going to do next is just go ahead and left click, yeah, my friends, just go ahead and left click to accept that, and it will bring out this create drawing window. Now, in essence, all of this will have been set up in the drawing sheet, but one thing I will need you to just have a look and check is this detail scale. Make sure it corresponds to whatever scale you're using for the plan and profile name boundary. Okay, so if this is the same 1 in 1000 as what we have specified here, then we are good to go. Just click on OK and let OpenRoads Designer works its magic behind the scene. Okay, so I've also added in super elevation data that you can actually target to. I will show this later on as part of the super elevation exercise, but right now just leave it blank is fine. I can just click on OK. All right, And here you will have the drawing with the title block in OpenRoads Designer. Okay, so you have the tabular annotation here with the proposed level as well as the ground level extracted, the vertical alignment as well as the horizontal geometry here with all the data as well as chainage. Okay, so same thing for the plan, whatever you have seen there, but with the addition of the north arrow sign as well as the northing and easting. Okay, so same thing in plan 1, this is what you'll be seeing. All right, and of course, if I were to go back now and add in my super elevation, let's see what happens, yeah, my friends. All right, so as what you have seen here, the super elevation row is left empty because there is no data to read from. So let's go back and add in a super elevation. All right, so I will just do this here under corridors. Okay, and I will just go ahead and create a super elevation section from beginning all the way to the end. Okay, and then I will just create the right and the left lane here, assuming that the width of the lane is 3.5 meters. Then I will create another one for the left lane, making sure I select the correct one, left lane. Okay, so you can see that I have now created left and the right lane, but the cross slopes are consistent throughout, even though even at the bends. Yeah, so there's not something that we want. Therefore, I would use the super elevation design rule. So I go into calculate super elevation, and then over here I can select the super elevation design rule based on ATJ 6%, 8%, and 10% maximum. So I can just go for 8% here, assuming. All right, open that up. So you can see now it changes to that. And I can change the design speed to either 40 like what I've used earlier, or I can use a different design speed. And it should pivot about the crown of the road. All right, so I will just select the super elevation section and then use the rule file to help me design my super elevation. Okay, and this is the super elevation for both the left and the right lane. If you're happy with this, okay, if this is correct, if not, then you can just go ahead and change the cross slope from here as well. Right, but now once we have the super elevation, you can see how the color codes change, especially at the bands, where it would just show us the cross slope. If we were to look at it, select it, you can see that here is a 7.4% cross slope, right? And then transitioning back to 0% here, and then back to the minus 3.33% normal crossfall. Now going back into the sheet model. But hey, we have the super elevation design, but where is the annotation? So I can just go into my profile view here. Okay, the profile model. And what I'm going to do next is I will go into drawing production and I will remove all the drawing model annotation. Okay, I will remove all the drawing model annotation, strip it of the existing annotation, and I will just simply re-annotate the model. Okay, so that I can pick up the super elevation data over here. All right, and once I do that, you will be able to see the tabular annotation being updated. All right, with the super elevation diagram being included as well. Now, because this is just a reference to the sheet model, whatever is updated there will be reflected in the sheet model as well over here. All right, so as you can see here. Okay, so all of that is interlinked from the design model, right? From the design model to your, what do you call it? To your drawing model, all right? This is what we call the drawing model. And then finally onto the sheet model. Okay, so all of this, the tags, annotations, the slopes, so all of this is being set up based on the drawing production standards, and of course the JKR title block as well. Okay, so So this is what I have for the plan and profile drawing production. Hopefully this is clear enough. All right. But before we go on to the Q&A session, all right, I would just like to share with you all regarding the cross section. What do you call it? The cross section drawing production as well. Okay. So for the cross section drawing production, I will just go ahead and create another file for the corridor model. Okay, I will just go ahead and create another file for the corridor model, and I will just name it corridor model. Okay, and I will save that. All right, so over here I have the corridor model. All right, design DGN file, and it's again another empty file. So what I need to bring in is I will just need to again attach some files over here. So I will just bring in my terrain model as well as my geometry model. So I will just bring in both of these models here. Okay. And again, of course, I would just be very careful now to just set everything to the correct geocoordinate system. Sorry about that. So library, projected, Asia, Malaysia. Oops. Sorry about that. So Asia, Malaysia, and ISO Sabah. Okay. So now I have this reference in, and I'm just going to go ahead and happily create my corridor now. Okay, so under the corridors tab, I will create a new corridor and selecting the centerline geometry here. Now, another reason why I wanted us to set the profile earlier as active, because you can see now, if I have set it as active, I can simply just do a reset, or in MicroStation term, a reset basically means your right mouse click to select that profile which is attached to the geometry. So I can just do a right mouse click here, and then I can just accept the name as GC20, right? That is fine. So left click to accept that. And you can see that there is this red boundary here. Okay, this red boundary here, which is the corridor boundary. And then I would just select a template, a typical cross section. All right, the template is a typical cross section. So I can use an undivided two lane, a simple one here, and apply it onto the whole section of this road. With a drop interval, now for the drop interval, it basically just dictates the accuracy of the model. All right, the closer the spacing, the more accurate it is in terms of the quantity takeoff. Okay, so I'm just going to use 20-meter interval, right? Just to show you the model part. And then you can see that in the 3D now, if I were to bring out the 3D model, view control, views plan / 3D, I would have the road cross section. But something is not right, isn't it, my friends? How come that this road is created with no slope, cut and fill, nothing whatsoever? Okay, and it's definitely not because it is very close to the surface, because we know that there's some huge amount of cut and fill based on my design profile. So what I need to do is I actually need to set this terrain as the active again in this file, so the corridor can actually react to it. All right, but why is it that after I set the terrain model as the active, the corridor is still not changing, right? Why is it still not changing? So I will need to just push the changes through by reprocessing my corridor. Okay, so I'm just going to process my corridor, select that, and then let it update, and you will see that the slopes, right, the daylights, cut and fill, will then be generated based on the, of course, the elevation of the existing ground. Okay. So with this now, what I want to do next is I will want to create our cross section drawing sheet. Okay. So to do the cross section drawing sheet, always remember to have both the plan and the 3D open. Okay, both the plan and the 3D model open side by side like so. Then I can just go ahead into drawing production again in the name boundary. Okay, I will use the place name boundary, and now I will select the civil cross section, and again using the Malaysia drawing sheet. Okay, and I will be using a detail scale of 1 in 500 for this one, and just go ahead and select the center line. All right, I will just create from start to end at an interval of 25, but if I deem that there are too many here, I can just go ahead and set this at every 100 if I like. Okay, so I can just manipulate the interval as easily as that. Okay, so maybe I will just set it at 50. Yeah, so we have a few more sample size to actually take a look at. All right, now what I'm going to do is I will simply just left click to accept the placement of this name boundary. And at the same time as well, I want you to take a look at the 3D model, where the moment we do that, all right, the same name boundary will be placed inside the 3D model. Okay, and the same create drawing dialog box will appear. I'm just gonna assume everything is right based on this. So the only one thing I'm gonna check is the detail scale, making sure that it is the same as what I have set up here. So 1 in 500 and 1 in 500. I am happy with that. Okay, so I will just go ahead and click on OK, and the rest I will leave it up to OpenRoads Designer to help me do it in the background. Okay, so I'm just gonna go ahead and sit back a little bit and wait for it to just generate out the cross-section sheets for me. Okay, so the moment that is done, you can see that all the sheets are created for us here, and it will automatically arrange for us. All right, it will automatically arrange for us the what do you call it? It will automatically arrange for us the cross section based on the space available. So it will not create one cross section per sheet. All right, it will actually create multiple cross sections per sheet based on the, of course, the space available. So it's just gonna optimize the whole space here. And if there's clashes like this, we can simply just go into, into our reference, because remember, all of this are simply just references. Okay, so I'm just gonna go ahead and move this, okay, so that it does not clash with my title block. So something like that. Okay, so you can see that the slopes are annotated, the cross fall of the road, the offset from the road center line, all right, the offset negative and then positive and things like that. Okay, so you have all the distance, the proposed road level and the existing ground level coming out here as well. Okay, so the proposed road level at this point is 111, while the existing ground is 117. Okay, so all this will be automatically annotated, and this will come into the sheet model where the title block is already placed. Okay, so that's for the drawing production aspect of things: plan, profile, and cross-section 2D sheet drawing production. And of course, all the standards that have been incorporated, which includes the geometric design standards as well as the super elevation design rules. All right, so yep, that is all I have for the sharing today, my friends. So I think now I will just open it up to the floor for any questions if there are any at all. All right. Yep. So thank you very much for your time on that. I think before we move on to the Q&A, Maylin has something else to share with you guys. So I'll pass it back to Maylin.
Okay, so just a little discussion on how you can again move forward. Okay, before we move on to our Q&A. Okay, wait. Okay, so I'm sharing my screen again. Wait. Okay, so for those who are keen on getting more information, Okay, so we have a lot of resources for you to use. Okay, of course, once you install OpenRoads Designer, you'll have the help, online and offline help, as well as the communities. Okay, the communities, you can, the Bentley communities. Okay, so communities.bentley.com. Uh, this is a free tool where you can register. Okay, and go to, let's say, for instance, the civil community, which includes open roads. Okay, so just click on whichever specific forum or information that you want to get. Okay, then apart from that, of course, if you already have a license or existing license of open roads, you can have an access to the learn server. We have some open roads learning paths there, as well as accreditations suited for roadway designers. And you can get 24/7 support by logging service requests to us. And of course, the our YouTube channel, we have quite a lot. And of course, in the Bentley website, bentley.com, you can go and register to other events, webinars, as well as uh, SIGs, we call it, user group. And then for those who are coming in from Open or MX, okay, in the communities, because I think some of you are probably would go for an apple to apple comparison between the commands, okay, uh, of MXROAD to OpenRoads Designer. So we have an MX to OpenRoads Designer equivalence videos. So there are quite a lot of videos already available for you. Okay, and we'll share the link to you in the chat, and we'll do that in a while. And then, as I mentioned, if you have an install or a license already of OpenRoads Designer, you'll get to have an access to the Learn server, which you have quite a lot of learning paths there, and some migration material or learning path on how you can migrate, as apart from the discussion that or the demo that Cornelius showed us. There's this one learning path there that allows you to really understand how you can migrate from MX to open roads. Okay, and then we have quite a lot of program. So regardless of you coming from other legacy softwares of Bentley, which includes MXROAD, we have a migration program specifically designed for you. We even cater for other softwares as well. And as I mentioned, you can have yourself accredited to us by being a Bentley Civil User accredited roadway designer. Okay, that's also accessible through the Learn server. Okay, and then we also have the education.bentley.com. So those who are in the education sector, although for now the free license for students and educators are still limited to these countries here. So we'll keep you updated for those who, because Malaysia is still not included. Okay, so we now open the floor for questions. Let's see the chat. Right. Right. Casey, do you have anything to add?
No. Do you want to go through the question or should I read it out?
You want? Yeah, we can. Please.
Mm.
Some we have already addressed, although of course we need everyone to also see it. Okay.
Okay, I think the first one is from Mahmoud Haslami. He's asking how to change the spiral rule from plotoid to a cubic rule.
Mm-hmm. For now, if you look at the settings, I think Cornelius, you want to share your screen for that so that you can orient them where to. Do you have it ready or
Yep,
not yet?
sure.
Okay, okay.
Okay, so here I have the settings which you can access via the backstage, or what we call the backstage. So all you need to do is basically just click on this file tab here, right? And then you can go over to the settings, right? And under the file settings, we have the design file settings, where if you look in OpenRoads Designer, the spiral type setting is just using Clothoid. All right. However, the cubic rule that you were referring to, we do have it, but it is only available in OpenRail Designer, where if you look at the drop down, we have all the cubic parabola rule. But again, this is only applicable if you are using OpenRail Designer. But as of now, if you are using OpenRoads Designer, what we do have is only creating a spiral using Clothoid. All right, so I hope that clarifies your question, Muhammad Haslami. Okay,
Yeah.
let's move on to the next one.
Mm-hmm.
Okay. Also from Muhammad Haslami, he's asking how to redesign an alignment on Bing Mac. Previously the alignment is using topo as a base, but it does not has coordinates.
So to redesign using Bing Map, does it mean that you're trying to do it using the Bing Map as an overlay, like what I did earlier? So if I may go back here, right? I'm assuming that what you're asking is, let's say we have the Bing Map as our background map now. Let's say Arial. Okay, so I assume the question is, how are we going to design it based on this Bing map, as per the previous way of me just importing in the terrain model based on the topo survey. So if I just want to do it based on this Bing map, right, I can design the horizontal alignment by simply going over to the geometry tab, and then I could either use the complex by PI tool, or I can just trace out the tangents and the curves and then complexing it after. So if I can just show it very quickly now, right, I'm just going to go over to complex by PI, and then assuming that I'm just using this design parameters here, and let me just sort of like reconstruct this road so I can very quickly just trace this out here, right? And yeah, it's not going to fit. So let me just change this down to smaller. Right, so potentially I can do something very quickly like so. But maybe again, I can just change this up a little bit to 250, for example. Okay. And we can just very quickly change or amend and update our alignment as per our project requirement, of course. All right. So using the Bing map as a background, we can just use the horizontal geometry creation tool to quickly design our geometry via placement of PIs. All right, the intersection points. Or we can just do it the conventional way, where we can just draw in our tangents, right? And then joining them out with a arc in between them, right? So similar to how we do it in a conventional way of designing geometries. Okay, so we can actually do this relatively quickly as well, based on, of course, the Bing map as the background map. Okay, I'm not sure if this answers your question, but I hope that this is what you were looking for. All right.
Okay.
Next
Yeah.
one.
If
Yep.
need be Muhammad Haslami, you can reach out to us after the session. Then we can talk a bit more about the what you're trying to achieve. Okay. So the next one is from Srinivas. He's asking, could you please explain also how to download the detailed topo survey data received from surveyors into OpenRoads?
Okay. So I think I gave a short explanation that we can support almost any survey data. Okay, maybe a raw survey data coming from fieldbook files, right? Or probably if it's in a DGN or DWG topo, so that's also possible. Okay. Now, Corn, can you switch to survey and then probably just show how they can the options that they have? Yeah. So if you click on let's say file import corn in no go back sorry there import that the just next to the file can it's the same tab field book, then you see a new field book, right? But there's another import panel. Yeah, there if you click that file, right, uh, then you just can you click the all the file types below? Yep, there. So we can import in different survey data. Okay, if it's coming from your conventional survey instruments, be it ASCII, uh, text files, or input files, coordinate files, and so on. Okay, but if it's coming from CAD, so all you need to do is just use some of our, tools in probably terrain modeling in order for you to convert that into terrain. Uh, I hope we address your question, Srinivas.
Okay.
Yeah.
Yeah, let's move on. The next question is from Mamat Haslami again. He's asking how to create bridge template with peer in ORD. So I guess you answered in the chat, but do you want to briefly go through again?
Okay. So if you would try to open a template, Cornelius, a sample one. The template actually it's like, the cross. Of course, it's the cross section that more or less literally extruding along the direction of your horizontal and your vertical geometries, right? So if you have a specific component that represents the pier, that would extrude it as well. So if you want uh, uh, to really model the pier, we have another solution or software which is called the Open Bridge Modeler that is really a software for bridge modeling. Okay, but for ORD, if you can show a sample bridge deck template, Corn, if you are, I think it's under rural or something. Or anyway, but you can only model the deck, okay, but still following the horizontal as well as the vertical alignment. Okay, now since Open Bridge Modeler is also microstation based and relies on alignment created by OpenRoads, yeah, that's it, Cornelius, thank you. So if you need to just model in the components and how it would really look like the bridge, I'm talking about the bridge, then we can create a template for the bridge deck. But of course, for the piers, you have to specifically use Open Bridge Modeler for that. Okay, but of course, the alignment, okay, still is dependent from OpenRoads designer, including the super elevation. If you have to add that as well. I hope that clarifies the question.
Okay, thanks, Milan.
Mhm. No problem.
The next question is from Srinivas again. He's asking, is there any specific format requirement like MX Genio file or AutoCAD survey data file can be used?
Actually, I think this is connected to to the survey data as well. um, we as we mentioned, we can import in any format that includes Genio, even AutoCAD, survey data. Okay, we're not actually limited to those formats as being shown here by Cornelius' screen. So yeah, we can support Genio, and we're not limited to Genio as well as CAD. Okay, and it depends on your workflow. If you have terrain data already, then you move to importing using the terrain tool. But if you will be starting from a survey data from your conventional data instrument or survey instrument, then you use the survey functionalities for that. Okay.
Okay.
Mm-mm.
All right, next one. I think it's more of a comment from Jordan Lee. He said that I tried modeling the corridor on open roads with slopes on multiple tier of cut and fill. However, the analysis could not be successfully performed. Maybe a future session can be held, particularly focusing on the creation of corridor template to address this issue. Yeah, should Jordan reach out to us personally?
Yeah, please, because I think it's just a matter of using the right template, and then adding in the right parametric rule, constraint, and priorities that you need to set in the cut and fill, or we call it end condition in OpenRoads. Okay. Yeah, just reach out to us so that we can address it specifically.
Right, Jordan. I'll share our contact email at the end of the session so that you can reach out to us directly. Okay. Oh, back to Mamat Haslami again. I think it's a clarification. He's asking how can I use Bing Map that show just as terrain model for the design alignment?
The Bing map is used just as a reference in order for you to know if your project is in the right location, right? That's why you have to assign a coordinate system, okay, the right coordinate system in order for you to I mean the right coordinate system in order for you to make sure that everything are in the right location or position. Okay, but to use that as a terrain, okay, no. The workflow in OpenRoad doesn't work like that, because it's just streaming the aerial photo as well as the map. Okay, but then if you need probably a terrain, okay, it's either because we also have a tool to import Google Surface. Probably you can use that tool, but you have to have Google Earth installed alongside with OpenRoads in order for you to extract terrain. Okay, but of course, if you're doing a detailed type of design, we should not be relying on this kind of data, right? So we have to rely on survey data or topo information that are really given to us by the survey team. Okay. So,
Hmm. Okay, I think
mhm.
that's about it for the questions. So yeah, I think Mama Aslami is asking for the recorded video session. Yeah, I guess wait, I'll just share my screen on the contact details. Um, all right, I think yeah, thank you, Malin and Cornelius, for the insightful presentation and demonstration on the MX to OpenRoads migration, as well as the demo on how to use the Malaysia dataset for JKR localization. So yeah, as promised, this is our contact email. You can contact me for commercial or sales matters. Milan or Cornelius for the technical matters. And of course, if you are served by any our channel partners in Malaysia, you can contact them directly if you have any of the commercial or technical question as well. So I guess for those who has joined as a guest in the session, including Mama Haslami and Jordan, I will appreciate if you can email me directly because I will not have your email address as a guest. So yeah, you can reach out to me so that I'm aware of your actual email address, and I will send you the link for the recording. And for the benefit of everyone, we'll be sending out the data set for you guys to try out as well. And also, we'll start a forum in our Bentley community for you to put up any queries or clarification which you would like us to address. So yeah, I guess after this, you will receive an email from myself containing all this link and data. So yeah, I guess we are at the end of the session. Is there anything else, Milan and Cornelius, you would like to add?
Nothing much. So just feel free to get in touch with us. And as Casey has mentioned, we do hope, because this exercise is not just for us to introduce the work in progress Malaysia dataset, but it's also for you to give us an input so that we can add more to the Malaysia country dataset. Okay, so it would be it would be best if we get it from you, the users, okay, so that we can improve on what is already available. Okay, thank you very much. Cornelius, anything else to add?
No, nothing else, Milan, Casey. Thank you all for your time, and yep, like what Milan has said, just feel free to reach out to us if you have any queries. Right? Thank you very much.
Right. Thank you so much for attending. See you in the next
Thank you.
session.